This is our first video on statistical inference. In this video, we'll talk about how to state the parameter of interest in a study, state the null and alternative hypotheses using both words and symbols, identify sample statistics, describe how to use simulation to test hypotheses about proportions, determine whether there is evidence to reject the hypothesis, and explain the meaning of a p-value in context. We'll refer to an example based on a research study done by Dr. Jarvis Bastian in the 1960s. Dr. Bastian was interested in studying dolphin communication. This example is discussed in Chapter 1 of the textbook Introduction to Statistical Investigations by Nathan Tintle, Beth Chance, and other authors. In the study, Dr. Bastian initially trained two dolphins, Doris and Buzz, by putting them in a pool together where there was a light that would either shine steadily or flash and blink. And then there were two buttons on the other side of the pool. The dolphins were trained to press the button on the right when the light was shining steadily, and to press the button on the left when the light was flashing. After both dolphins learned of their task, they were then separated by a curtain put in the middle of the pool. Doris, the dolphin, was put on one end of the pool with the light, while Buzz was put at the other end of the pool with the buttons. The dolphins could hear each other through the curtain, but they couldn't see each other. Doris was then shown the light, which was either shining steadily or blinking. And then Doris would have to communicate to Buzz whether to press the button on the left or on the right. Buzz, after hearing Doris's whistle, would press one of the buttons. If Buzz pushed the correct button, both dolphins were rewarded with fish. In 16 attempts in the study, the dolphins pressed the correct button 15 times. We're interested in whether this result provides evidence that the dolphins were truly communicating with one another, as opposed to randomly guessing which button to push. We'll perform a statistical investigation to check into this. Let's start with some basic terminology. A sample is a subset of individuals or outcomes of interest, in this case the set of 16 attempts by Doris and Buzz. A statistic is a numerical property of that sample. In our situation, the statistic would be the proportion of attempts that Doris and Buzz got right, 15 out of 16, or 0.9375. When a statistic is a proportion, we'll use the symbol a p with an accent mark over it, which we call p hat. While the statistic pertains entirely to the sample, a parameter pertains to a long-run property of a process or population. We might be interested in knowing if Doris and Buzz had repeated this experiment many times, would they continue to keep getting it right? The parameter in this situation would be the proportion of times that the dolphins pressed the correct button if the experiment were repeated many times in the long run. When the parameter is a proportion, we'll use the letter P without the accent mark or the hat symbol over it to represent the long run proportion. In the study about the dolphins, we have one of two explanations for what's going on. Our first hypothesis or explanation would be that Buzz was purely guessing which button to push. The other explanation would be that Buzz was not just guessing and was actually getting information, possibly from Doris or possibly from somewhere else, and using that information to decide which button to push. We have specific definitions or terms for these hypotheses. Hypothesis number 1, that Buzz was purely guessing, is referred to as the null hypothesis. If this was the case, then the true parameter, the true probability of Buzz pressing the right button in the long run would be 0.5. If Buzz really was getting useful information from Doris or from somewhere else, then Buzz would have greater than a 50% chance of pressing the right button, so P would be greater than 0.5. We call this second hypothesis the alternative hypothesis. In general, a null hypothesis refers to the explanation that something is happening by chance alone. The alternative hypothesis is another explanation that contradicts this null hypothesis. The key question we want to investigate is, how likely is it that the dolphins would have gotten 15 or more out of the 16 attempts correct if they were just guessing which button to push without communicating? We need to determine the probability of getting a result as extreme or more extreme than we did, that is, getting 15 or more correct, if our null hypothesis is true, that is, the dolphins are randomly guessing. We'll do this by simulating a situation where the null hypothesis is true. If Buzz is purely guessing and has a 50% chance of pressing the right button, we can simulate this by flipping a coin and letting heads represent pushing the right button and tails represent pushing the wrong button. In the second video, we'll perform this simulation and see what our results tell us about dolphin communication.